In this video, you will learn how to compare properties of functions when they are represented in different forms. Functions can be represented in many different ways, such as by an equation, a graph, a table of values, or a verbal description. When looking at the different representations of functions, some important properties to look for are the slopes of linear functions and the x and y intercepts of all functions. How do you determine these properties from the different representations of functions? In an equation in f of x equals mx plus b form, the slope is m. To determine the x-intercept when given an equation, substitute 0 in for f of x or y and solve for x. The values will be in the x values of the x-intercepts. To determine the y-intercept when given an equation, substitute 0 in for x and solve for y. The value will be in the y values of the y-intercept. In a graph, the slope is the ratio of the change in y values to the change in x values between any 2 points on the line. This is represented by the formula m equals the difference between y2 and y1 divided by the difference between x2 and x1. The x-intercept is where the graph intersects the x-axis. The y-intercept is where the graph intersects the y-axis. In a table, the slope is the ratio of the change in y values to the change in x values between any 2 rows of the table. So the same slope formula can be used as for graphs. The x-intercept, when shown in a table, will be represented by a row with 0 as the y value. The y-intercept, when shown in a table, will be represented by a row with 0 as the x value. In a verbal description, the slope is the rate of change when the function is increasing by the same amount for each interval. X-intercepts might not be stated in a verbal description. They would be the inputs where the function value is 0. For instance, the time at which the height of an object is 0 may be represented by an x-intercept, or the days until an account balance is 0 may be represented by an x-intercept. The y-intercept, if described, is the starting value when the input variable is 0. Let's look at an example of how to compare different representations. The equation and verbal description each represent a different linear function. How do the slopes and y-intercepts of f of x and j of x compare? First, determine the slope and y-intercept for each function. The equation is already in the form f of x equals mx plus b, so the slope is m, which is 4, and the y value of the y-intercept is b, which is 2. The y-intercept is 0, 2. Convert the verbal representation of j of x into an equation to make it easier to determine the slope and y-intercept. 3 less than means you will subtract 3. Twice the value of x is 2x, so 3 less than twice the value of x is 2x minus 3. You can now write an equation for j of x. Look at the equation to identify the slope as 2. The equation also shows that the y value of the y-intercept is negative 3, so the y-intercept is 0, negative 3. Now answer the question, how do the slopes and y-intercepts of f of x and j of x compare? The slope of f of x is twice that of j of x. F of x also intersects the y-axis 5 units higher than j of x. Let's look at another example. The function f of x is represented by the graph, and the function g of x is represented by the table. How do the x and y-intercepts of f of x and g of x compare? First, let's find the intercepts of f of x. In a graph, the x-intercepts are where the graph intersects the x-axis, and the y-intercepts are where the graph intersects the y-axis. So, the x-intercepts of f of x are -3, 0, and 1, 0. And the y-intercept is 0, -3. For the table, the x-intercepts are represented by rows with g of x equal to 0, and the y-intercept is represented by the row with x equal to 0. So the x-intercepts of g of x are 1, 0, and 5, 0, and the y-intercept is 0, 5. Now answer the question, how do the x and y-intercepts of f of x and g of x compare? The x-intercepts of g of x are each 4 units to the right of the x-intercepts of f of x. The y-intercept of g of x is 8 units higher than the y-intercept of f of x. Let's look at one more example. The function f of x is represented by the table. The function h of x is represented by the equation h of x equals 2 to the x plus 1 power minus 4. How do the y-intercepts of f of x and h of x compare? For the table, the x-intercepts are represented by the x values in rows with f of x equal to 0, and the y-intercept is represented by the y value in the row with x equal to 0. These things both happen on the same row, the row with 0, 0. So, 0, 0 gives both the x-intercept and the y-intercept of f of x. To find the y value at the y-intercept of h of x, substitute in 0 for x. 2 to the first power is 2, and 2 minus 4 is -2. So, the y-intercept of h of x is -2. Compare the y-intercepts of f of x and h of x. You can see that the y-intercept of f of x is 2 units higher than the y-intercept of h of x. Now you know how to compare properties of functions when they are represented in different forms. Thanks for watching.